right, we're gonna do a little shortcut of graphing cube roots. If you have the parent graph, which is in the very last video in detail, I chose -8, -1, 0, 1, and 8 as the domain because, well, you can have a negative under a radical as long as the index is odd. And what I did is I chose numbers that had perfect cubes, like the 1 and the 8, and then of course the 0. I did that on purpose. All right, so that I'd get whole number answers. So let's graph these and look at the parent graph for the cube root of x. Go back 8, left 8 and down 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. There's a point. -1 is left 1, down 1. 0, 0. Right 1 up 1. And right 8 up 2. Okay, this is what your typical cubed root graph looks like. Okay, that will be the parent graph. Now, the one that I'm going to graph, like it, is a negative cube root of x plus 2. And just like all the other transformations that we've done, the negative is a reflection over the x-axis. If the a is negative, I'm reflecting over the x-axis. And this is an h here, the plus 2. It started out as a minus a number. So the only way I'm going to get a plus 2 is if it started out as minus a -2. That would make it a plus 2. So my h is -2 and I need to go left 2. So if I take all these points and I go left 2 and then flip over the x-axis, I've got my new points. And that's just a fast way to do it. If there is an a here, like a -2 or some number here, you're going to have to use your t-chart. But in this case, the t-chart's not necessary. So just take every point, go left 2, and flip over the x-axis. So left 2, this is 2 below the x-axis, so I'll go 2 above the x-axis, and I've got that point. Take this one, left 2, he's 1 below the x-axis, go 1 above the x-axis. This is 0. Left 2, and since you're on the x-axis, don't move. This is 1, so I got to go 2 to the left, and then I am 1 above the x-axis, so I need to go 1 below the x-axis, and I'll be on a different point, the point I've already had. And then here, I've got to go left 2, and he's 2 above the x-axis, so I'll go 2 below the x-axis. All right, and then when I graph them, I'll have that. Now, you may wonder, well, let's see, what were those? Could I check those with algebra? And yes, I can. This is, the x is -10, there it's -3, -2, -1, and 6. And if you plug those numbers in, this is what your y's will be. And you could go back and try your algebra to see, did you do that correctly?